example with you. This one is going to be a little bit harder just because it's going to be 2 steps. So let me show you what that looks like. So this question says, how many molecules are in 92.3 grams of NO2? So as always, we need to figure out what our given is. So in this case, we have 92.3 grams of NO2. So our unit here is grams, and I'm circling the NO2 because that's also really important to know in this example. And so we're trying to figure out how many molecules. So that's our goal. That's what we're trying to get to. That's what we want to know. And so I've written up here our 2 conversion factors that we just learned. So the top one is Avogadro's number. That tells us how many particles are in a mole. And if you remember, particles can mean different things. So particles can actually mean, here we go. Particles can actually mean atoms, if that's what the question is asking for. Or particles can also mean molecules, if that's what the question is asking for. It can stand for a lot of different things. So we need to keep that in mind in this example because it asks for molecules. So that means it is asking for a number of particles, okay? So off the top of our head, we don't know a conversion factor that tells us how many particles are in how many grams. All we have is how many moles are in how many particles, and then we also have our second conversion factor, which is molar mass, and tells us how many grams are in how many moles. So we don't have one that goes there from molecules to grams. So what that means is we're going to have to do 2 steps. And so let's see what that's going to look like. So first of all, we need to figure out what the molar mass of NO2 is. So remember that the molar mass is going to be all of those different elements, what their molar mass is added together. So let's start with nitrogen. So nitrogen, we're going to look up on the periodic table and see that it has a molar mass of 14. And we're going to multiply that by 1 because we only have 1 nitrogen. And then oxygen, if we look it up, has a molar mass of 16. But we have 2 oxygens. So that means we're going to have to multiply that by 2. Whenever we add this up, we're going to get 46 grams per mole. So that is the molar mass of NO2. So what that means is up here in our conversion factor, we can fill in that 1 mole is equal to 46.0 grams. Now, I am going to be rounding off some of these in the examples, so just be really careful with your rounding. If it's really, really close, we can round to a whole number, but for the most part, we want to keep our decimals the same. If it's 0.4, keep it 0.4, okay? But if it's like 0.99 or 0.01, that's really, really close. So those are the only ones that we can really round to a whole number. So moving on, we're going to go ahead and start to set up our T-chart. So first thing we always want to do, as always, is put our given right there. So 92.3 grams of NO2 is going to be our given. And remember that when we set up our T-chart, we always want our units to cancel out. So what that means is if I have grams of NO2 right here, then I want to make sure that I also put grams of NO2 down here. So what that's going to look like is this. We're going to take our conversion factor that we have up here, which is grams, and we're going to stick that molar mass on the bottom. And since our molar mass is 46, we have 46 grams of NO2 on the bottom. And on the top is going to be that 1 mole. So once again, this is our conversion factor. So this is our conversion factor of our molar mass. So our molar mass tells us that there are 46 grams of NO2 in 1 mole of NO2. So moving right along, right now our units we can see cancel out for grams of NO2. But what we're left with is moles of NO2, so we need to keep going. We're not ready yet because we're looking for molecules. Don't mix up molecules and moles, okay? Remember, molecules is a number of particles, so we have to keep this T-chart going. So if we add another step, then our unit that we have right now is moles of NO2. So since that's the unit that we have, that's the unit we need to cancel out. So that means that moles of NO2 is going to need to go on the bottom. So if we look at our conversion factors, our only conversion factor we have left is Avogadro's number. And Avogadro's number says that 1 mole is equal to 6.02 times 10 to the 23rd particles. So 1 mole of NO2 needs to go on bottom. That way our units are going to cancel out just like we would like them to. Moles of NO2 cancel. And since 1 mole of NO2 is equal to this many particles, that's the number that's going to go on top. And all of our units are canceled out except for molecules of NO2, and that's what we were looking for originally in the question. So that means our T-chart is done, and we're set up. All we have to do is multiply across the top and divide by the bottom just like always. And if we do that correctly, we should end up with this answer. So go ahead and type that into your calculator. Make sure that you're getting the correct answer. Because remember, you do need to multiply 92.3 times 1 times 6.02 times 10 to the 23rd, and then divide by 46 and divide by 1. And if you do that in the correct order, that's the answer that you should get. And that's it. That's how you do two-step mole calculations. You're going to have to do this anytime you're going from grams to molecules or grams to atoms, or if you're going from atoms to grams or molecules to grams, you'll always have to do 2 steps like this.